Okay, so after recapping whatever we have studied in thermodynamics, today we'll try to solve some numerical examples, some problems on thermodynamics. Okay, so I have put one numerical. Okay, so this is not directly related to first law of thermodynamics, but prior to that we have studied about specific heat. So it is related to that. So the question is, what amount of heat must be supplied to 2 into 10 to the minus 2 kg of nitrogen? Nitrogen is at room temperature. To raise the temperature by 45 degrees centigrade at constant pressure. Okay. Nitrogen molecular mass, its nitrogen atomic number is let us say 7. Okay. So nitrogen atomic number of nitrogen is 7. Okay. So nitrogen molecule formula is N2. Okay. So atomic number means its number of protons. Okay. So if it has 7 protons, it will have 7 neutrons also. Okay. So as you know, you have you have a nucleus. You have a nucleus. So inside nucleus you have proton plus neutron. You have proton plus neutron. Okay, and outside nucleus you have electrons. Like the first cell will have 2 electrons, and then next cell will have another 5 electrons. Okay, three, four, five. Okay, so this is your nucleus. These are our electrons which are negative charge. This is electron which are negative charge. Okay, inside this is proton plus neutron inside the nucleus. This is nucleus. Okay, so this is nucleus. So inside the nucleus you have proton plus neutron. Okay, so neutron is why neutron? It is neutral charge, no charge. Proton has positive charge, proton positive charge, and electron negative charge. Right. So atomic number is nothing but a number of protons. Okay. So these are 7 protons are there inside. So if there are 7 protons, there has to be 7 neutrons also. So if there are 7 proton plus neutron, the total for a nitrogen N is one nitrogen atom. So in one atom, the mass will be 14. Okay. So 14, and in one molecule it will be 14 into 2, that is 28. Okay, so that is mass of one nitrogen molecule, and then 1 mole of nitrogen molecule is nothing but your 28 kg. That is, we have studied that 1 mole is nothing but 6.023 into 10 to the power 23 molecules. If that many number of molecules will have mass of 28 kg. Okay, so so that's why okay. So I have just wrote it here. Can you just read out and tell me that 12.2, actually I have written, whether I have written it correctly or not? Just read it out.
What amount of heat must be supplied to 2 into 10 power minus 2 kg of nitrogen at room temperature to raise its temperature by 45 degrees Celsius at constant pressure? Molecular mass of N2 is 28. Universal gas constant R is equal to 8.3 joule mole inverse Kelvin inverse.
Yeah. So I have written correctly then. Okay. So what amount of heat? So we have studied like our Q. Q is equal to M, and it is happening at constant pressure. Okay. So it is for a gas there are two things. Like for a solid there is only one C. specific heat. Okay. But for gas, there are two things. One specific heat at constant pressure, one specific heat at constant volume. So Q is equal to, in this case, it will be mCp, right? It will be mCp into delta T, right? So if the rise in temperature had happened at constant volume, we would have written Cv. And because it is nitrogen, you are thinking about Cp and Cv and all. If it is iron, or if it is steel, or if it is aluminum, solids, we will have only one thing, neither Cp nor Cv, only C. Okay. So what is the amount of heat that will be required? Okay. So mass we know, del T we know. Okay. Then Cp we have to find out. Okay. So okay. So yeah. So we know R. Okay. Uh, so knowing R, how do we find out the Cp? Hmm? No, no. We have the R. Okay. Mass we know. Okay. Mass we know as 2.0 into 10 to the minus 2. Right. Del T we know it is 45, because whether it is Kelvin or centigrade, del T, like let us say in Kelvin, it will become, like say initial temperature T1 will be 273 plus 45, 273 plus some temperature. Okay. Let us say it was at 0 degree, let us say. Okay. So this is in Kelvin, right? Let us say T2 is equal to 273 plus 45. That many Kelvin. So that means T2 minus T1 in Kelvin will become again 45. So whether it is in degree centigrade or whatever, it will be 45. So we know del T is 45. We know mass in kg is this, and we know R. Okay, but we want Cp. How do we get that Cp? Without Cp, we cannot get the amount of heat. So what is that Cp? You know R, a molecule raise the temperature at 45 degrees centigrade at constant pressure. Raising by 45 degrees centigrade at constant pressure. So if you are doing it at constant pressure, it should be Cp. So you know R. How to find the Cp? Okay, let us see. Uh, Okay, so we have derived in earlier. Actually, that part while studying thermodynamics, we have not touched it. So from it is something like this. Actually, your uh, your specific heat at constant pressure Cp is nothing but your 3R. 3 into R. This is one important relationship, just you remember. Okay. So this is based on actually kinetic theory of gas. Okay. Like this is based on kinetic theory of gas, which will be studying later. Okay. So just remember Cp is equal to 3 into R, capital R. So I know my R is equal to 8.3. So 3 into 8.3 joule per mole inverse Kelvin inverse. Okay. So you got to know your Cp, you know your mass, you know your Cp, you know your delta T. So you know Cp is this, you know delta T is 45. So after replacing all the three values, you can find out what is the value of Q. Okay. So to solve this problem, you what is the amount of heat required? You need to know three things. What is the mass of the nitrogen? Okay. So the mass of nitrogen measured is 2 into 10 to the minus 2, which is nothing but 0.02 kg. So you convert it into kg. 0.02 kg. Okay. So this is nothing but 0.02 kg. Okay. Cp is 3R means 3 into 8.3, which is nothing but it will be 24.9. Okay. 24.9 joule per mole inverse Kelvin inverse. Clear? So you know Cp, which is this value, and you know mass, which is 0.02, and you know delta T, which is 45. So whether it is centigrade, whether it is Kelvin, the delta T value remains same. So after replacing all these things, you will get the result. Okay. So the from by solving a numerical, you become clear about the units. Units are very, very important in physics, especially in thermodynamics and heat transfer related stuffs. Okay. So now you got to know that okay, R is unit is joule per mole per Kelvin units. Where from you got this R unit? Because you know PV is equal to NREL, whatever. Okay. So N is number of moles. So R is equal to Pg by NP, right? So you know Pg is nothing but your work done unit. Okay, pressure, the work done. So that is joule, then mole, then Kelvin. So from that equation itself, you are getting the unit of R, which is nothing but the universal gas constant. Okay, and delta T anyway you know Kelvin, and mass you know anyway kg. Okay, so what is 1 mole and all that also I have explained you. Okay, so this is one numerical. So you try to you take a picture of this, try to solve it in your notebook. Okay. Just, okay. So you solve it and compare it with the answer and tell me whether it is coming the you are able to match the answer or not. You solve it and do it and show it to me. Okay.